Hi y'all, I hope you're doing well as possible. I wanted to make a quick video to help you with today's cool down for algebra. So I know you've heard this from your teachers and you've heard it from me, but just to say it one more time, your revision for algebra is this cool down basically. So your project that you've been working on, it's all going to be summarized in this cool down, the day 7 cool down that you'll be doing at the end of class today. And this is what your teachers are going to grade this weekend. If your grade on this cool down is higher than your grade on the exam that you took right before we left school, then it will improve your grade. So this cool down can't hurt your grade, but it can help and improve your grade for, it's going to count as the revision for this unit. Again, ask questions if that doesn't make sense, but just know that this cool down is important for how your final grade will be calculated. There are two main things that you'll be asked to do. The first is you already have your equation written from earlier this week, the day 6 cool down. You're going to be asked to predict the number of COVID cases on April 14th. And then that's like the first main thing, and I'll show you how to do that. And then the next main thing you're going to do is predict when there will be 3 million COVID cases in the US. So I'm going to model this for you using Leslie's equation. Thanks, Leslie. I stole this from Ms. Murphy. This is Leslie's equation that she's using to model COVID cases in the US. And I'm going to use it to make our predictions today. So if I were Leslie, the first thing I'm doing is I'm going to try to predict the number of COVID-19 cases on April 14th. Okay, this is not easy, this is hard. I have an equation, and I'm trying to use the equation to predict how many cases there will be on April 14th. So first, let's go through the equation and just remind ourselves of what it even means. I think that will be a helpful first step. So let's see, again, sorry that I'm trying to learn how to do this online, but bear with me. So again, Leslie has this 18,747 number. That's her initial value, how many cases she thought there were at the beginning of her time period. One important thing to keep in mind is that for all of your models begin on March 20th. So let me just make a note. This is going to be interesting to see if I can write on this. Begin on March 20th. So that will be important later. So there are this many cases on March 20th. The 2 is her growth rate. Let's show that in a different color. So we know by now this is always the initial value. This is always the growth rate. And then the D, it's actually convenient that she chose a D as her variable because the D is representing the number of days. And that's going to be I'm so sorry for my handwriting. So that's going to be the input into the function is how many days it's been since, let's be specific, days since the beginning. In this case, we said our beginning was March 20th. So let's say we'll annotate this as days since 3/20. Okay, thank you for bearing with me. Okay, so days since March 20th, and then the output of our equation, let's choose a different, so the input is the number of days since March 20th, the D. She has the days over like 1 with a denominator of 1. We don't need to have the denominator of 1 because dividing by 1, D divided by 1 is just D. anything divided by 1 is just itself. So I'm actually going to cross this out just so we don't get confused later on when we're calculating. So she could have just written her equation. It would have meant, this is me crossing it out. It would have meant the same thing if she just said the 18,747 times 2 to the power of d. Nice, clean, simple. I like it. Okay. This output on the other side, the C of D, so the input is the days since March 20th. The output is going to be the number of corona cases. So number of, oh God, this is embarrassing. Okay, number of COVID cases. So now that we figured this all out, back to the question. Predict the number of COVID-19 cases in the US on April 14th. So what I'm going to do is I'm going to figure out the number of cases on April 14th. I'm either going to be plugging in something on the left side of the equation or plugging in something for the variable, plugging in for D. Because I know how many days it's been since March 20th, I'm going to be plugging in a number for D. And then as my answer, I'm going to get out the number of COVID cases. So the number of COVID cases is like my unknown. It's what I'm trying to figure out. And the number I'm going to plug in is the April 14th because that's what I know. Let me show you what that looks like. That'll make more sense once I show you. So I'm going to leave this side as C of D. So I'm just going to copy that down. Try to make this more neat. And then I'm just going to write my equation same as it is up here, but I'm going to replace D with a number. We'll get there when we get there. So I'm going to go 18,000. Can obviously skip this part so you don't have to watch me struggle. Multiplied by 2. Now, what on earth am I going to plug in for D? How many days has it been since March 20th on April 14th? That sounds like an answer we can find in the calendar. So if my starting date is March 20th, I can just count the number of days between March 20th and April 14th. So I could count by weeks because each week is going to be 7 days. So I could go 7 days, 14 days, 14 days. So it's been 14 days here, and then it's been 21 days here, 21, 22, 23, 24, 25. So it's been 25 days on April 14th. So I'm going to go ahead and plug in 25 for my exponent, plugging in 25 for my D. D represents how many days it's been since March 20th. Oh, let me move this. And on April 14th, it's been 25 days since March 20th. Okay, so now I just have to plug this into my calculator to get my final answer. I'm first just gonna copy down this. So this is, oops, the number. That is not a good look. How can I erase this? Okay. The number of corona cases, C of D, equals, and then I'm just going to plug this into a calculator to get an answer. I recommend using Desmos. You can use Desmos on your phone as well. So it is, what is it? 18,747 747, is that right? 747 times, I'm going to put this in parentheses, 2 to the power of 25, oops, close parentheses. Okay, that is going to give me, ooh, that's ugly. It's going to give me a very big answer. Let's see, maybe if I Google this, it will give me. Sometimes we can use just the regular Google calculator and it will give us an easier answer. So let's go, or yeah, an answer that makes more sense. So it's 18,474 times 2, let's not forget our parentheses, times 2 to the power 25, close parentheses, and there is our very long answer. Ooh, that's very long. I would just copy and paste it into the cooldown, and that would be your answer. You can put the commas every 3 numbers. So essentially it's going to be 619,884,576,768. And that would be our prediction for the number of cases on April 14th. Okay, and I'm just going to write that into my final answer here. It's going to end up being about 619. I'll use the about sign, the wavy. 619 billion cases. Okay, so that is how you predict the number of cases on April 14th. Use your own model. Obviously, everyone's model is going to look a little differently. I just wanted to show you how to do it using Leslie's model. Okay, so basically you just plug in 25 for the exponent for D. Hope this was helpful. I'm going to make another video for the second part of the cooldown. Thanks for watching.